Welcome to a series of short educational videos which describes important concept of building performance. Today we'll be pondering using systems when describing building performance. Here's our statement. The concept of building simulations and the quantification of building performance is directly connected with the concept of system and process of system analysis. Since we understand that not everybody of you might be comfortable of thinking about systems, let's think in terms of system. Let's start. And what do you think is a system? And I would like to suggest that you think about it for a while, pause the video, write down your thoughts, and when ready, continue to view this video. As a matter of fact, there are several definitions. One, which I really like, is the following. A system is an interconnected set of elements that is coherently organized in a way that achieves something. And this definition was done by Ms. Meadows, and she was the co-author of Limits of Growth, a very famous book. Following this definition, a system needs three kinds of components. First, function, elements, and interconnections. So we have a function. We actually define what it actually is good for the system. We have elements, and we have interconnections. So all three components are important if we have a system or if we deal with a system. Let's look at a schematic. So here we have a house or building, and we have a lot of stuff in there. And first of all, a building is a system. We're saying it is a function, it has elements, and interconnections of these elements between themselves and to the outside world. Let's start with the function. So we have a function, and the function of a residential building is as follows: provide healthy, safe, and cost-effective shelter and an uplifting place to live. So the building, the function of the residential building is not only to provide some kind of a physical place to live, but it also is something uplifting, something for the soul. Next, we have elements. So here we have the empty shell, we have elements, and the building elements, has multiple layers of systems, and the systems in systems. And we'll see this, why we say systems in systems. Then we have interconnections. And how do systems interconnect? And where do we draw the boundary? This is a really important thing, and it not only helps us, it makes our calculations and quantitative performance description of a system, of a building, very much easier. So important to define the boundary of the system. The upper one, see, we have a system where the only interconnection is defined as having the electric grid, whereas the other one down there is another boundary. Whereas the boundary is only around the outline of the house, and we could say that the PV system, the solar water system, the AC, and the electric car is outside of the system. Both description is okay, and but they only influence how we define the performance. Let's take a closer look. So on one side we have the real system, and you see this as a schematic, a lot of moving parts and all kinds of stuff. On the right side we see a mathematical abstraction of the system, because especially if you want to have quantifiable answers, we need some kind of way to quantify and to define numbers and to calculate numbers. And we can see this as follows. The mathematical description allows calculating of numerical values. And numbers are very important for quantifiable performance, of course. And we've used building simulation as an effective tool to describe and quantify the performance of the building. So we have taken our first step in understanding what systems are and what are they good for, just to get a very broad idea. And let's see how much you remember. And again, like, we use this self-learning assessment, and it will actually help you to understand it better. And also we encourage you to speak with your friends and colleagues. It sometimes it helps a lot if you try to define, something and explain something to other ones. So the first one is, what is the definition of a system that you can agree on? What are the three components of the system which we discussed? What is, for instance, the function of a building where we apply systems on buildings? And why is it important to use mathematical abstractions to describe the system? So I'd like you to ponder it. And this is the end of our short video, and we thank you again for your interest, and please join us again for another video in the future.